So the first thing we're going to do before we do the special factoring today, we're going to look at just taking our calculator and learning how to factor with our calculator. So take x squared minus 3x minus 4 and put it into your y equals. X squared minus 3x minus 4, put it in y equals. So now, if we factor this, they show the factorization for us here, that if we factor this, that we would get x minus 4 and x plus 1, right? And we actually just factored that anyways, right? Factors of negative 4 that add up to negative 3, negative 4, and 1. Right? So, right? And graph it in your standard viewing window, so zoom 6. Now, the key to this is notice where does the graph cross the x-axis at? All right, and this is actually going to help us for chapter 9 too then. Where does it cross the x-axis at? Okay, negative 1 and positive 4. Okay, so if we go back and look here, so at negative 1 and positive 4, it crosses the x-axis. Well, how do negative 1 and positive 4 compare to the numbers that we have in the factored form? How do they compare to x minus 4 and x plus 1? Carson? They're opposites, okay? All right? Where it crossed the x-axis at negative 1, in the factored form is x plus 1. Cross the x-axis at positive 4, and it's negative 4, or x minus 4, in the factored form. All right, so let's look at another one. All right, so graph x squared minus x minus 2. X squared minus x minus 2. There you go. You turn the plot off. All right, so if we factor this, what are the factors of negative 2 that add up to negative 1? Okay. Negative 2 and positive 1. So this would be x plus 1 and x minus 2. All right, so now look at the graph of x squared minus x minus 2. Where does it cross the x-axis? Okay. At negative 1 and positive 2. So these, it crosses the x-axis at the opposites of the numbers we put in factored form. Okay? So I want you to use your calculator then to factor these other ones, 2, 3, 4, 5, and 6. All right? So you're going to have factors just like we have here, x plus 1 and x minus 2. All right? But I want you to use your calculator to find them. All right, so for number 6, when we graph that one, we can see that our places where it crosses the x-axis are at negative 6, so 1, 2, 3, 4, 5, 6, so negative 6. So we've got x plus 6. But the other one is not exactly on a spot, right? One of the whole numbers. Okay? Close to -1, or +1, but it's not there. So now, here is how I encourage you to use your space between your ears creatively. Okay? Now, I don't actually need to know what that is, all right, to be able to finish this problem. Because when I multiply x plus 6 times this, I'm going to get that, right? Yep. Okay. So, x times what is 3x squared? 3x. So 3x goes here. And 6 times what equals -12? -2. There we go. We just factored it. So I didn't actually have to know exactly what the second one was to be able to factor it. If I knew the first one, then I could just figure out what the second one is, because when I multiply them together, they got to give me the answer. Okay? So that makes it kind of easy. All right? So you can use your calculator to assist you with factoring. You just have to make sure that you write them in factored form. You just don't find those zeros that they're called, or x-intercepts. Right? And we'll actually talk more about them in Chapter 9 then, because that's one of the biggest things we're going to be doing, is finding where the quadratics cross the x-axis. All right, so we have two special products for factoring that we're going to look at now. One of them is called perfect square trinomials, and they look like this. If we have a squared plus 2ab plus b squared, then we get factored form of a plus b times a plus b, which I can write as a plus b squared. Or if the 2ab is negative, then we have minuses there. So, x squared plus 6x plus 9. When I factor that, factors of 9 add up to 6. They're the same, 3 and 3. So if I have a perfect square trinomial, it just means that these two things are going to be the same. All right? Which means I can write it as just 1 being squared, Mr. Parker. Okay? All right. Or x squared minus 2x plus 1. Factors of 1 add up to 2, or add up to -2, -1 and -1. So I can write it as x minus 1 squared. So this is why it's important that you know what the squares are. So you should either make a list of them somewhere on a paper somewhere, your notebook, wherever, or at least be able to put them in your calculator, y equals x squared, so that you can find them. All right, so if you're unsure of what they are, if I just put x squared in my y equals and go to my table, I can see all the squares. All right? So for what we're going to be doing today, you need to know these numbers. All right? And if you don't know them, then you should make a list of them somewhere so it's easy to find them, so you don't have to worry about the calculator. All right? So what I'm suggesting is that you write them down. Okay? All the way to 15, no. So make a list of the squares up. All right, so we want to determine whether a trinomial is a perfect square. If it is, we're going to factor it. If it's not, we're going to explain why not. All right, and our explanation is basically going to just involve numbers, okay, or showing the work. So, we want a squared minus 2ab plus b squared, right, is what this has to be in that form for us to be able to have a perfect square trinomial. So what we need to do is we need to find out the value of a and the value of b and see if they're squares first of all. And then if they are, we have to look at the middle term to see if it works. So, is 9x squared, is that a perfect square? Okay. So what is squared there then? Okay, 3 and x. So I'm going to write this as 3x. That's what's squared here. Right? Which means that a is equal to 3x. And I'm going to write that down a little bit lower to help me with this. Okay. All right, 64 then. So I'm looking at this third term. Okay, is that a perfect square? Okay, so if I look at my list of squares, yes, 64 is on there. That's 8 squared. All right, so this is 8 squared. So that means that b is equal to 8. Right? So the big question is now, we have a squared and b squared. Is this thing here in the middle, is that equal to 2 times a times b? All right? So the big question is, does 15x equal 2 times 3x times 8? Okay, and Charlotte's shaking her head no. All right? Because 2 times 3 is 6, and 6 times 8 is 48. All right? So 15x does not equal 48x, so this is not a perfect square. Trinomial. All right, and I'm showing that because the 2ab part doesn't work. Okay, so we check to see if the first term is a square. We check to see if the last term is a square. If they are, then we have to check the middle term to see if it's equal to 2 times the first term that's squared times the third term that's squared.
S through W, please go to room 102. Anybody left at the end of the alphabet, please go to room 102, take your Chromebook, and everybody has to go.
All right, so look at B, 81x squared plus 90x plus 25. All right, we're looking for a perfect square trinomial. Now, here's the thing, all right? Our two factoring methods we use for b squared, or for ax squared plus bx plus c, all right, the box method or the other method, if these are perfect square trinomials, they'll work. Okay, so you could use one of those methods to factor it. So if you didn't recognize it to begin with, you could always just use one of those methods to do the factoring. Right? So, 81x squared, is that a perfect square? Okay, that's 9x is being squared there. All right, so we've got 9x is squared here. All right, what about 25? Is that a square? Okay, so this is 5 squared. All right, so the question is, does 90x equal 2 times 9x times 5? All right, so that's the big question then. If that's a true statement, then this is a perfect square trinomial, and we can factor it. All right. So 90x equals 2 times 5 is 10, and 10 times 9 is 90x. All right, awesome. So then, when I factor this, it will be 9x plus 5, that quantity squared. All right, you don't have to write it as two separate ones, you just write it as one because it is a perfect square trinomial. All right? Okay, letter C. So if it's not a perfect square trinomial, you need to show why it's not, and then say it's not. If it is, then you just need to find it. Right. Letter C, is that a perfect square trinomial? Okay, why not, Charlotte?
36x is what?
Right, get the 14. Okay, all right, so since 14 is not a square, so it's not a perfect square trinomial. Okay. So those are easy. Okay. All right. Okay, a rectangular piece of cloth must be cut to make a tablecloth. The area needed is 16x squared minus 24x plus 9 square inches. The dimensions of the cloth are in the form cx minus d, where c and d are whole numbers. Find an expression for the perimeter of the cloth. All right. That's the first thing. So we got two things we're doing here. Find an expression for the perimeter. Right. And then we are going to find the perimeter. So we're talking about a rectangle. All right, here's a rectangle. How do I find the perimeter of a rectangle? Okay, we add up the four sides. Okay, we add up all the sides. So what we need to know is how long is each side. Okay, so I have to take this trinomial and factor it. Well, so I just look at the ends to start with. Okay, are they perfect squares? Okay, if they are, then this is really easy problem then, because it says it is a rectangle, so it must be 4x, and because this is a minus sign here, it's minus 3. Right? Because 4x is squared here, and 3 is squared there. And so one of the ways you can check to see if it's a perfect square trinomial also is that you could just write them like this and then do this multiplication of these two and add them together. And if they give you the middle term, I'm golden, right? What's 4 times 3? 12. And if I double 12, what do I get? 24. Okay? So this is a perfect square trinomial. And so that's an easy way to do this also. Okay? Write what you think it is, multiply those two numbers together, and then double them. Okay? So we have 4x minus 3, and 4x minus 3, and 4x minus 3, and 4x minus 3. Oh, this isn't just a rectangle, it is a square, which means all the sides are the same, so the perimeter is just 4 times 4x minus 3, right? So when I use the distributive property, we get 16x minus 12. And that is in inches. So if they want us to find the perimeter when x equals 11, we just do 16 times 11 minus 12. So the perimeter of this tablecloth be 164 inches. And so I would write that. The perimeter of the tablecloth is 164 inches. Right? So don't forget to do that. Write a sentence. If it's a word problem, it needs to have a sentence with it that explains what the answer means. I like to hear it better the other way. There you go. Perfect. All right? So perfect square trinomials. Okay, the other thing we're going to look at today then is what's called the difference of two squares. All right, so we're still working with squares. But when we say the difference of two squares, well, what is it? What's a difference problem? Okay, a subtraction problem, all right? So it says difference of two squares because there's a subtraction problem going on. So if I have a square minus another square, when I factor them, I get the first one plus the second one times the first one minus the second one. All right, so write this down. Difference of two squares. All right, here's what you get when you factor them. So when we're factoring difference of two squares, first of all, we've got to see if they are squares or not. If they are squares, then we write the first one plus the second one times the first one minus the second one. All right, so go ahead and try to do both of them. So if it's not a perfect square, explain why not. If it is, then factor it. And then I'll do them for you. Okay, Leah, how about letter A? Is that a perfect square, or is that a difference of two squares? No. Okay, why not? All right. Because 3 is not a square. All right, so this is not the difference of two squares. Okay? All right, letter B. Johnny? All right, so what do I get when I factor it? All right, good. We have 10x is squared to make 100x squared. 2y is squared to make 4y squared. So I say 10x plus 2y and 10x minus 2y. Good. All right. Those are some of my favorites because those are the easiest thing to factor. All right. If you find the difference to two squares, those are usually the easiest ones to do. All right. So here we have a letter C. X to the fourth minus 25y to the sixth. Okay. And this is the difference of two squares. Just sometimes it's harder to see what they are. But when we have even powers, the thing that's being squared, the power is half of what that one is. Okay? So in this case, our things being squared are x squared is squared there. And this one would be 5y to the third power. Right? Just got to cut the power in half. So this would be x squared plus 5y cubed and x squared minus 5y cubed. All right, that would be it.